All right, ready to unlock some secrets. Today we're taking a deep dive into a world where, well, sparkle meets serious tech. We're talking computational jewelry design. Ever looked at like a crazy intricate ring or a necklace where every little stone is perfectly placed and just thought, how?
It's a question I'm sure we've all asked ourselves at one point or another. And honestly, the answer is pretty cool. It's this blend of, that classic artistry, but then this whole other layer of tech.
Our guide for this deep dive. It's a course syllabus on computational and parametric design for jewelry. And I got to be honest, at first glance, when I saw entire chapters on like circles, I was a little lost. Circles, really.
I can see why that might not sound super exciting right off the bat, but if
Yeah.
you think about the essentials of jewelry, rings, bands, those settings, it all comes back to that basic circle.
Okay, yeah, that makes sense. So it's like in the physical world, a jeweler picks up a length of wire to shape. But here, instead of tools, we're talking algorithms and software, like what is it, Rhino and Grasshopper.
Exactly. And that's where things get really cool. Chapter 8, manipulating circles to create rings and bands. It shows how designers aren't just like drawing circles on a computer. They're using code to basically mathematically define every part of those shapes.
So instead of eyeballing it or making these teeny tiny adjustments by hand, they can be incredibly precise, changing the diameter, the thickness, like down to a microscopic level.
You got it. And here's where it gets even wilder. This whole thing called parametric design. So you set up these relationships between the different parts, and if you change one thing, let's say that initial circle size, it automatically updates the entire piece.
Wait, back up. That sounds kind of magical. So if you decide, actually, I want a slightly thicker band for this ring, you don't have to redraw every single element.
Nope. Parametric design is like these ripples, the changes flow through everything seamlessly. Huge time saver. And the flexibility is amazing. You can play around with tons of variations without starting over each time.
Okay, that's a game changer, especially for those super intricate pieces where one tiny tweak by hand could take, like, hours. Now, speaking of intricate, I have to ask about the chapter on pave and supports. For those who haven't had the pleasure of wearing a piece with pave settings.
We're talking about that technique where you have tons of these tiny, tiny gemstones set super close together so the surface just sparkles, like no matter which way you look at it.
Exactly. And to do that well by hand, it's insanely difficult. But this syllabus, it's suggesting that even pave, as intricate as it is, can be designed digitally.
Oh, absolutely. Chapter 19 gets into how algorithms can define where each and every stone goes, so the spacing's perfect, the look is consistent across the whole piece. Imagine trying to do that by hand, the precision needed.
It's like having this digital apprentice with superhuman steadiness. I also noticed supports mentioned in that chapter. What are those in the context of pave?
Those are the little, almost invisible structures that hold those gemstones in place. They're like tiny prongs or claws stopping those precious stones from, well, falling out. The syllabus suggests that even those can be designed digitally, so each stone is held securely but also elegantly within the piece.
Wow. So we're controlling not just where each stone goes, but the mechanics of how it's held there, all in this digital space. It's kind of blowing my mind. This reminds me, I saw chapter 9 earlier, cutters. And I was curious, what are cutters in jewelry design and how does that even work digitally?
Good question. So traditionally, cutters are the tools jewelers use to carve out the exact spots in a piece of metal where the stones will be set, almost like chisels or drills, shaping the metal super precisely.
Okay, so how do you recreate that digitally? It seems impossible.
That's where 3D modeling comes in. The syllabus talks about using software to make these like virtual versions of the cutters, factoring in the stone's exact shape, the setting style, even how thick the metal is.
It's like having a virtual toolbox filled with every cutter you could ever need, all perfectly engineered. No more searching for the right tool or painstakingly shaping it by hand.
Right. And like we were talking about with those rings and settings, the beauty here is that you can adjust things on the fly. Need the setting a bit deeper for a particular stone, just change a few settings in the software and boom, the virtual cutter adapts.
It's incredible how this course takes the artistry of traditional jewelry making and combines it with these cutting-edge digital tools. And it sounds like it's not just for beginners either. I spotted a chapter near the end, tips and tricks. It feels like I could have some great insights, even for seasoned pros.
Yeah, chapter 20, we don't have all the details, but it probably covers those little insider techniques, those workflow optimizations that make a big difference for someone who uses this software day in and day out.
So things like shortcuts, maybe how to customize the interface for certain tasks, those little efficiency hacks that save hours in the long run.
That's the idea. I wouldn't be surprised if it touched on stuff like file management, those rendering techniques for gorgeous visualizations, maybe even tips for collaborating in a digital design space.
Like a masterclass on top of everything else.
Uh,
But before we jump ahead, let's go back to something for a second. Those twisted cables, the complexity of those designs just screams computational power.
Chapter 15, that's where the magic happens. And you're right, to create those interwoven patterns by hand, talk about a test of skill and patience, but digitally. It opens up this whole new world of what's possible when you combine that mathematical precision with artistic vision.
All right, you've definitely piqued my curiosity. Let's untangle this whole twisted cable mystery and see what secrets are hidden in this syllabus.
Let's do it. This is where things get really good. Ready to unravel those twisted cables?
Oh, absolutely. They're like tiny, perfectly braided sculptures. So how do you even begin to create something like that digitally?
Well, chapter 15 lays it all out. First, you define the basic shapes that'll be woven together. Could be simple cylinders, maybe something more complex, but imagine like these strands of virtual gold just waiting to be shaped.
Okay, so those are our building blocks. What then? Do you just tell the computer, all right, start twisting?
You're getting there. The syllabus talks about rotating these elements around an axis. It could be a straight line, that classic cable look, or even a curved path for something more, I don't know, whimsical. And by adjusting the angle, the frequency of that rotation.
You control how tightly those strands are woven together. That's wild. It's like a digital spinning wheel, but for metal.
Nailed it. And because it's all happening through code, the possibilities are endless. Change how many strands there are, make them thicker, thinner, even adjust the tension of the twist, all in just a few clicks.
Talk about a shortcut to mastering a seriously complex technique. This is way cooler than my friendship bracelet days, that's for sure.
Oh.
But I'm guessing that level of control is key when we're talking about fine jewelry, not just fun experiments.
Oh, absolutely. Think about the precision needed to create those intricate woven patterns in, like actual precious metals. By hand, that takes years to master. But with these digital tools, designers can play with those techniques in a whole new way and with incredible accuracy.
It really shows how this isn't about replacing those traditional skills. If anything, it's like enhancing them, pushing them even further.
100%. And that's what's so exciting, this back and forth between old and new. It's pushing the boundaries of what's possible. But actually, you mentioned earlier how Chapter 7, analyzing and manipulating curves, seemed super important. What was it about that?
Well, we talked about circles, but so much of jewelry, especially when you look at vintage pieces or anything inspired by nature, it's all about those flowing organic lines, not just perfect circles and straight lines everywhere.
You're right, and that's where Chapter 7 comes in. It's about understanding how to create those curves digitally, how to control them, which is essential for capturing that sense of movement, that fluidity.
It's almost like teaching the software how to be elegant, how to create something with grace instead of just like rigid geometry.
Perfect way to put it. The syllabus even mentions things like dividing curves, extending them, aligning them to specific planes. It sounds technical, but those are the tools for creating those beautiful flowing forms.
It's giving me flashbacks to geometry class, but in a good way.
Think of it more like digital sculpting. Instead of clay, you're using equations to mold and shape those virtual lines.
Okay, now that's a much more appealing image. So once you've got those curves down, what are some of the real-world applications in jewelry design?
Oh, remember those dome rings we touched on earlier? Those rely heavily on understanding how curves work.
Ah, right. Those classic rounded bands, very vintage feel.
Exactly. And Chapter 13, Dome Rings 1, that probably dives into the techniques for creating that signature domed shape digitally, making sure those curves are perfect, super elegant.
But then there's also dome rings too. 2D cross-sections. What's that all about?
Now that's where things get even more interesting. Using two cross-sections, that suggests creating much more complex forms, maybe bringing in those twists, those intricate patterns we talked about.
So taking that classic dome shape but adding this secret layer of complexity. Maybe a twist you only see from a certain angle or a pattern that flows perfectly along the curve.
You've got it. And that's what makes this field so cool. It's this beautiful blend of technical mastery, but also artistic expression, all coming together to make these tiny works of art.
Speaking of art, remember those pave settings? Practically miniature sculptures, some of them. I'm dying to know more about how those are tackled digitally.
You read my mind. Let's dive into the world of pave and see what makes those shimmering surfaces tick.
All right, let's talk sparkle. Pave settings. It's like, how did they even... It's like they sprinkled stardust and said, time to make jewelry.
It's definitely a statement piece, and it really shows off just how precise this digital approach can be.
So where do we even start with something as intricate as Pave? Where do you even begin?
Well, Chapter 19, that's our roadmap.
Yeah.
Remember how we were talking about algorithms controlling where each element goes? With Pave, it's taking that idea and applying it to all those tiny stones, making sure they're evenly spaced, yeah, but also angled perfectly so they catch the light just right.
It's like I don't know, a mathematical ballet, but with diamonds instead of dancers.
That's a great way to put it. Like a choreographer planning every move, the designer can define exactly where each stone sits, how it's tilted, how it relates to all the others. Art meets computational power. It's really something.
And it's not just about how it looks either, right? We touched on supports before, those tiny little structures holding everything in place.
Oh, absolutely. Chapter 19, it seems like it gets into digitally designing those supports too. Whether it's those delicate prongs or sturdier claws or even something more complex, it's all in there.
So it's like building this tiny invisible scaffold just to cradle those gemstones. And because it's all digital,
You can make sure those supports are strong, definitely, but also that they're elegant, really subtle, so the stones can really shine.
it's mind-blowing how this technology lets you control those tiny details, the ones you might not even notice right away, but they make all the difference.
Yeah.
And speaking of details, let's go back to those dome rings for a sec. We talked about using 2D cross-sections to create some really intricate shapes, but what does that actually look like? What kind of designs come to mind?
Okay, so imagine a dome ring, right? But instead of that smooth curve, it's got this subtle twist, almost like a ribbon. Or picture the dome itself having a hidden pattern, something you only see when the light hits it just so.
Now, those are some serious jewelry design secrets.
No.
I can definitely see why this is becoming such a big deal. But with all this talk about software and algorithms and, all the tech stuff, it's easy to forget there are still incredible craftspeople out there making jewelry by hand the traditional way.
Absolutely. Those skills, the techniques passed down through generations, that's something we can't forget. This technology is amazing, but it's not about replacing that.
Exactly. It feels more like, I don't know, an evolution rather than a revolution.
That's a great way to put it. It's about giving designers more tools, more ways to express their creativity, and yeah, pushing those boundaries, seeing what jewelry can become.
Well said. This whole deep dive, it's been amazing. I had no idea there was so much math and technology behind these beautiful, sparkly pieces.
It just goes to show beauty can come from the most unexpected places. And in the world of jewelry, that blend of art and innovation, it's definitely shining bright.
So true. Next time you're admiring a beautiful piece of jewelry, take a second to really appreciate it. Not just the finished piece, but the journey it took to get there. The designer's vision, the skill involved, maybe even a little bit of code working its magic behind the scenes.